wave function with KT dependence, by which depend on the hadron mass, and they have the convolution. Okay, so this I can convolute this universal vector and with this the KT distributing function. Then I can vary this m to see how large the effect is. Then you do the test.
Another question. Yes, sir. You mentioned that Collins showed that when you next time leading order, you cannot do factorization, but you effectively define the phase factor to do the factorization. Right. So that's an effective way of doing it.
Yeah, effectively, yes. So in the most strict definition, KT factorization still fails because we have to introduce additional non-perturbative inputs. So if you insist the most stringent definition, I agree, KT factorization fails. But if we relax this constraint, if it's allowed to introduce more non-perturbative problems, can we say we restore the KT factorization? If you agree, then yeah, this one. Yeah.
How do you define these two Wilson lines, positive and negative?
Oh, you have the Wilson line definition. You know Wilson line definition. Yeah. Yeah, it's n dot a. Okay, now you just walk from infinity to infinity along the minus direction, infinity to infinity in the plus direction. Certainly, in principle, you should have these two are linked at the infinity. We have vertical links because they separated by a distance b. This b will measure it's in a Fourier space, so you have a b dependence. But you go to the moment space, you have an LT dependence. Yeah, so you can vary this b, and then you can measure.
B is in the position space or in momentum space?
Position space. B is the position space.
This is Lycon?
Lycon. Yeah, strict Lycon.
This has never been discussed in language.
Well, we cannot do Lycon. It's a trouble.
Yeah,
there's no
right.
So it's actually not doable.
Not that I know how to do it. If it's defined on the Lycon.
It can be done in ADS-QCD.
ADS-QCD.
Yeah. Yeah. Because I remember the Liu Hong has considered a similar definition in Rick physics. Yeah, they want to calculate the so-called KT broadening. In fact, I checked his paper, found that they write down the same definition as mine. Same definition. Quite interesting. So this effect appears everywhere. Yeah.
Okay, I thought the two Wilson lines are parallel.
No. Not really. Not necessarily parallel. You mean in the Liu Hong's definition?
Well, they calculated this parallel. They should be calculated quite back to back. Right. So there should be 1 plus 1 minus direction, but they somehow calculated parallel.
So this one is more complicated. It's a
I have a question. So could you say those new phase this new phase is associated with the property of pions? I would think you need 3 hadrons to work together in order to have this effect.
Right.
So that should be a common property between 3 hadrons, not just 1 pion.
Right.
But
so
this definition.
Yeah. So in principle, for the complex process involving 3 hadrons, we have this effect. But then the next question is, because it's a non-perturbative, which hadron can give you the strongest effect? Which, yeah. So it really is flavor dependent. But certainly, I can.
That when you have just 1 pion without 3 hadrons, this effect doesn't appear.
You can see, no hadron is pion.
Just
if no hadron is pion,
hadrons get involved.
Yeah. Then
this
no. According to my argument, this effect only is important only when pion is involved. So if more pion involved, its effect is stronger, like D to pi pi, B to pi pi.
Yeah. Right. So this will come out automatically, or you have to
no,
it's
not automatically. It's my argument, and I can only give a not very solid proof like that one. I convolute this universal effect with this KT distribution function. I can show that when the hadron mass decreases, this effect increases. Yeah.
Right, but it seems in this description, if you just have 1 hadron which is pion involved, you still have this state.
Or if it's a process, so you're talking about simple process. Yeah. No way. Because you need the 3 hadrons involved to provide these global gluons. Okay. If there are only 2 hadrons involved, no way to provide the global gluons.
From the Wilson line.
Yeah.
Okay, I think the students are dumbfounded. If there are no further student questions, I think we should close. Any questions from the students? Just trying to ask. Apparently not. I mean, professors can go offline and discuss more. So let's thank Professor Li again.